Hey, what's up, guys? So, today I'm gonna solve this problem, and what's special about it is that we're gonna solve it using the quadratic formula. So, let me read it out to you guys. A shot putter throws the shot with an initial speed of 14 meters per second at an angle of 40 degrees to the horizontal. Calculate the horizontal distance traveled by the shot if it leaves the athlete's hand at a height of 2.2 meters above the ground. So I think we should start by drawing a diagram. You see this guy? He's the shot putter, and he throws the shot. He's really tall, 2.2 meters tall. He's up here where it's shot. And then, just a second. Let me move this drawing down so I have more space. Now, we draw the shot going like this and landing on the ground. So, yeah, if you watched my video from yesterday, you'll recognize that in this question, the object lands at a different height from when it is launched. And because of this, we have to use the quadratic formula to solve it. So, the first step, notice how it says gives us 14 meters per second. Whenever you see that, we should start by drawing the vector diagram for the initial velocity. So this angle is 40 degrees. This is 14 meters per second. And we can also find this component, which is Vix and Viy. And this Vix is equal to 14 times the cosine of the angle, which is 40. And this Viy is equal to 14 times the sine of the angle 40. So you can calculate these right now if you wanted to, but I prefer to calculate them at the end, so we don't have to have some messy numbers in there. So now for the next step, since the so 40 meters, 2.2 meters above the ground. So we should start usually by using the formula d equals 1 over 2 at squared plus vit. And then d is negative 2.2 meters because the ball starts at 2.2 meters high, then it goes down, ends up 2.2 meters lower than where it started. So then that equals half of 9.8, or negative 9.8. I'll just do that in my head, which is negative 4.9 times t squared, which we don't have yet. And also VIT. So right now, we're solving for vertical. We're using vertical components right now. So VI would actually be VIY. Let me write that in. VIY. And that's 14 sine 40. Sine 40 times t. Then what I would do now is move these two terms over, so we can have a quadratic equation. And then we can, after we did that, then we can actually use the quadratic formula to solve this. It's 2.2 meters equals 0. So now that we have this, yeah, I think now is a good time to simplify this. 14 sine 40t. So, didn't bring my calculator out. Just give me a second. 14 times sine okay, so sine 40. Okay, this calculator is weird. So sine of 40 equals 0.6427 around, and then multiply that by 14. And we get 8.999. I usually round up to 4 sig figs just to make sure my answer will end up being still accurate. So now we use the quadratic formula, negative b plus or minus square root of b squared minus 4ac divided by 2a. So our b is negative 8.999, so negative 8.999, so that's positive 8.999 plus or minus the square root of 8.999 squared minus 4 times 4.9 times negative 2.2 divided by 2 times 4.9, that's just 9.8, so we'll leave it at that. Let me just get here. So yeah, start by squaring the 8.999, and then I usually just do this part in the radical on my calculator because it's kind of a nuisance to write it all out. So square 8.999, do plus, because there are two negatives here, they cancel out. So 4 times 4.9 times 2.2 equals 124.1, and then square root that, and we get 11.14. 9 plus or minus 15 divided by 9.8. So if remember what variable we're solving for, it's time, because that's our variable in this equation. So we should write t equals and before all of these. So then we can realize what answers we should accept and which ones we should reject. So if we do 8.999 minus 11.14 divided by 9.8, then that would give us a negative number. And t can't be negative in this question because we're looking after he throws the ball, not before he throws the ball. So we have to reject the minus 11.14. So that leaves us with the other option, 8.999 plus 11.14 equals 20 point something divided by 9.8 equals 2.00555, and that's seconds. When I'm doing these questions, it's usually better just not to write the units because they can mess you up sometimes and they take a while to write down. So next, what we're actually looking for is the horizontal distance. But we right now have time. So to find the horizontal distance, we need to look at the horizontal vectors in our equation. So all that is Vix, which is 14 times cosine 40. And there's no acceleration. So to find the distance, it's just dx equals Vx times t. Vx is 14 times cosine 40 and times t, which was 2.055 seconds. And if we put that all into our calculator, times 14 times cosine 40, I get, oh, I'm in radians, oops. So 14 times cosine 40 times 2.055. It gives us 22 meters. And that's our answer. Just to check if the sig figs are right, usually check at the what values it gives you. 14, 2.2, those are both 2 sig figs. So that means the answer will probably be 2 sig figs. And yeah, that's how you solve this equation, this problem. So thanks for watching, guys. I'll see you in the next video.